time you have water being added to a substance, what's going to happen is you're going to also have the water is going to be splitting up into H plus and OH negative ions. Keep that in your head. So with dilute solutions, remember that dilute means that it has more what? We look at this diagram, do you have more of the ion or do you have more of water? You have more of water. So dilute solutions mean you have more water present. So because you have more water present, your hydroxide, which is OH negative, will be in higher concentration. So as a result, OH negative is going to be discharged at the anode. So we're going to see what that means later on. Now with concentrated solution, do we have more of the ion or do we have more water present? Look, there's only two water molecules, so we have more of the ions. Very good. So what does this mean for us? This means for us that because the concentration solutions contain more bromine ions, the bromine will be in higher concentration. As a result, bromine is going to be discharged at the anode. That's what that means for us. If we remember, the cathode has a negative charge and the anode has a positive charge. The cathode, therefore, because it has a negative charge, is going to be attracted to the positive ions. And the anode, because it has a positive charge, is going to be attracted to the negative, negative, negative. So here we have the electrochemical series, and this is just a series of elements, a series of ions, positive ions and negative ions on the right. And it's telling us the order in which the ions are going to be discharged. So which of these ions is going to get a chance to, which of these positive ions is going to get a chance at the cathode? Which one of them? Which one of these negative ions are going to get a chance at the anode? Okay, so if we look at the ions, it is important to know that the ions further down are going to be the ones that are going to get that chance, the ones that are going to be discharged, because again, it's going to require less energy for those to be discharged. So here we have some electrolytes, and we have them in different kind of environments. One of them is in a molten form, the other one is in a dilute solution, and the other one is in a concentrated solution. Don't forget how it changes when the solution or when the kind of substance that it's placed in is different. So if we look at magnesium chloride molten, we know that in a molten form there's no competition because because it's not in a solution, there's no competition. So at the anode, if we look at our chart, at the anode, what should we have? At the anode, we should have our negative ion, okay? Because the anode is positive, so it attracts to the negative. So which one is our negative? Chlorine, very good. So that's going to be the ion at the anode. Now, what about the ions at the cathode? The positive ion, right? Because the positive is attracted to the negative cathode. So you're going to have magnesium, okay? Magnesium plus 2 because he's in group 2 and he's going to lose 2 electrons. That's it. All right. Now, with dilute and concentrated solutions, remember now we have water. They are in a solution, so we also have water being broken down into H plus and OH negative. So now we have competition. So in a dilute solution, we said at the cathode, it's going to be H plus unless you have copper or silver. So most of the times at your cathode, you're going to have H plus unless copper or silver is present. At your anode, if it's in a dilute solution, you're going to have hydroxide being discharged. That is what this chart is telling me. Why is it that hydroxide is being discharged? We have to remember now that with a dilute solution, remember you have more water present, so you have more hydroxide present. So at the anode, the one that's going to be discharged is going to be the one that is in higher amounts. That's how you remember it. Okay, so at the anode, because it's a dilute, you have more of the hydroxide. So OH negative is going to be discharged. So you're going to have competition. Remember what I said? So you have chlorine from the magnesium chloride, and then you also have hydroxide coming from the water. But the one that we said is going to be preferred is the hydroxide. Very good. Now the ions at the cathode, it's always going to be hydrogen, because for the cathode, the positive ion, we always use this chart, and whichever one is lower in the reactivity series, that's the one that's going to be discharged. So we have magnesium all the way up here and hydroxide all the way up here. It's going to cost us less money to pick hydroxide, so hydroxide is going to be the one that's going to be preferred. Okay, so even if we look at our chart here, here, it says it's always going to be H plus at the cathode unless copper or silver is present. That's because copper and silver, they are below hydrogen. Okay, so now let's complete this chart. So the ions at the cathode would be your what? So you're going to have magnesium, that's the positive ion, and you're also going to have hydrogen. Okay, but the one that's going to be preferred, we said, is hydrogen. Good. Now for concentrated magnesium chloride, okay, the same concept applies. At the anode, we have the -1. Okay, which one is the negative? You're going to have magnesium, right? Very good. Chlorine, good. So you're going to have the negative ion, so chlorine and hydroxide. Now, which one is going to be preferred? Okay, now remember, we think about which one is for the anode, we have to think about which one is existing in a higher amount. Remember, in a concentrated solution, you have more of the negative ion. You have more of the negative ion, so this is why you're going to have chlorine being discharged. Okay, and if you also look at your chart, it says that if a halogen is present, that's the one that's going to be discharged, or the negative ion is the one that's going to be discharged. So at the cathode now we have our, very good, we have our positive ions, which is our magnesium and our hydrogen. But there's competition. Which one is going to be preferred? Remember, for the cathode, we always use the series, and whichever one is less reactive at the bottom, that's the one that we're going to prefer. So because hydrogen is still below magnesium, we are going to select him again. So now you can go ahead and you can practice this, do it the same way that we just did it, rewatch the video, and then you can go ahead and practice this and show it to me next class, and this will be graded. So make sure you complete it. And you also have another one. So this is another one. I want you to go ahead and complete this one the same way that we did the first one. I want you to go ahead and complete this one.